Hi, it's Miss Young. Welcome back to part 3 of the Conic section series. This time I will discuss ellipses, features of the curve itself, as well as how to write an equation, and then how to then graph the resulting curve based on that equation. Here we see another double napped cone. And what we're after this time is being able to intersect the cone with a plane through just one of the cones, but this time not parallel and not perpendicular to the base. So we're just slicing the cone without regard to parallel or perpendicular. And if that happens, we create an ellipse, which you may know as an oval. This gives you a chance to check your vocab. You were supposed to visit a couple of websites to get the answers to the different parts of the ellipse. So take a moment and check those. You may want to press pause and then play again after you've done checking and making corrections. Now for the equations of an ellipse. We see here again our general form of ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. In the case of the ellipse, a and c cannot have the same value. They must be different values. B is still equal to 0. We'll have no rotations of ellipses. And we have to pay attention to the sign of a and c. They must both have the same sign, either both positive or both negative. Now for standard form of the ellipse, we're looking at two different versions. Know that now we have fractions, x minus h squared over a squared plus y minus k squared over b squared equals 1, gives us the equation of an ellipse whose major axis is horizontal. And then x minus h squared plus y minus k squared, where b squared is the denominator for x and a squared is the denominator for y, gives us the equation of an ellipse whose major axis is vertical. In trying to determine which number is a and which number is b, a is always greater than b, as a is the length of the major radius. Now take some time to grab your graphic organizer to help with this part of the lesson. We are going to write the equation of an ellipse given certain information, and then we will take some time to graph that ellipse as well. Please pause the video now if you need to grab that sheet. Now that you have that sheet, let's get started. We want to write the equation of an ellipse where the vertices are located at coordinates -4, 4, and 6, 4. And the foci are located at coordinates -2, 4, and 4, 4. Now, if you were to do just a really quick sketch of what this ellipse might look like according to coordinates, if this is -4 on the x, and this is 6 on the x, then I have a vertex here. Well, that's not true. This is going to be 4 on the y. I have a vertex here and here, -4, 4, and positive 6, 4. And then I have foci at -2, 4, and positive 4, 4. So that tells me that my major axis is a horizontal major axis. So that gives me an indication of which equation I should be working with. Now I need to know the length of A. You can do that in a couple of different ways. I'm going to show you using the distance formula, that we can find the distance from one vertex to the other, which will give us 2a, and then if I take half of that, I'll have the value of a. So for the major axis, again, it has a length of 2a from vertex to vertex. So I'm going to use the distance formula here, which is the square root of the x coordinates subtracted from each other, so -4 minus 6 squared, plus the difference of the y coordinates subtracted from each other, 4 minus 4 squared. And if you do some quick magic on your calculator, you'll find that this distance is 10, and again, this is 2a, the length of the major axis. If I then solve for a, I'll find that a is 5, and this is the length of the major radius. So 10 is the length of the major axis. A is the length of the major radius, which is half the length of the axis itself. Now the other piece of information we're given has to do with the coordinates for the foci, and there is a special relationship between the major radius, the minor radius, and C, which is the focal length, and that relationship is that C squared equals A squared minus B squared. B is the length of the minor radius, so I will need A and B in order to write this equation, but I'll need to find C to help me find B. So what I'll do is I'll take the information that I've been given for the focal points and find the distance between those, which is 2C, and take half of that, which will help me find C. So using distance formula again, but this time with the foci, the difference between the x coordinates, -2 minus 4 squared, plus the difference between the y coordinates, 4 minus 4 squared. And again, using your calculator, you'll find that the value this time for D is 6, and this is really 2 times C. And if I take half of that, dividing both sides by 2, I'll find that C is 3. And C, again, is called our focal length. It's the distance from the center of the ellipse to either of the foci. Now if I go back and use this equation, C squared equals A squared minus B squared, that will help me find the value of B. So substituting, C is 3, so C squared is 9. A is 5, so A squared is 25. Minus B squared. Now again, with some algebra, you'll be able to manipulate this equation and see that B squared is 16, and so B is 4. Because B represents the length of the minor radius, we know that length is positive, and there's no need to consider that B could be -4. So what I have so far that's needed to write my equation are values of A and B. Now I just need to know the center, which will give me H and K in the equation itself. Now the center is the midpoint of the vertices. The center is also the midpoint of the foci, and the center will also be the midpoint of the co-vertices had we been given those. We can choose either one. You can choose your foci or your vertices. I'm going to choose vertices. So to find the center, we're interested in finding the midpoint of the vertices. Your midpoint formula requires you to average the x values, so -4 plus 6 divided by 2 would be the x coordinate, and then average the y values. 4 plus 4 divided by 2 would be the y coordinate. So our center is the midpoint 1, 4, and remember that represents the coordinate h, k. Last part, remember we said that we knew that our major axis was horizontal, and so the major axis is longer than the minor axis. The value of A is bigger than the value of B, and so we will use the standard form that is written as x minus h squared over A squared plus y minus k squared over B squared equals 1, and we'll substitute into that formula. So this is the equation that we'll use. So when we make our substitutions, h is 1, so this becomes x minus 1 squared. A is 5 over 5 squared, which is 25, plus y minus k, which is 4 squared, over b squared. B is 4, but b squared is 16, equals 1. And this is the equation of the ellipse that has vertices at -4, 4, and 6, 4, also at -2, 4, and 4, 4. You may want to pause again and take a look at what we've done, or take some time to copy down things that you didn't have a chance to copy, and just press play when you're ready. Okay, now that you have reviewed the algebraic part, let's now look at how we can graph the ellipse that we've just written the equation of above. I've scaled my axes out. Feel free to take some time to scale yours out as well. And we're going to start, as we usually do, at the center. So the center of our ellipse is at 1, 4. And so we'll make sure that we graph that. Let me choose a different color here. So 1, 4 is our center. And from the center, we can get some other information using the values of A, B, and C. We know that the vertices are located at -4, 4, and 6, 4. I'll put those in red. -4, 4, and then at 6, 4. The co-vertices are located at -2. I apologize, that's not true. The foci are located at -2, 4, and 4, 4. I'll put those in green. And then to find our co-vertices, remember that the minor radius was 4. So if I begin at my center and go up 4, since the minor radius is vertical, that's 1, 2, 3, 4. I'll put that in pink. And then go back to the center and count down 4. 1, 2, 3, 4. Again in pink. That is our co-vertex on either end. So we're going to go back and label these. The pink are co-vertices. The red are vertices. The green represent the foci. And the orange represents the center. And so now when we draw in this ellipse, we want to draw a curve that goes from co-vertex to vertex to co-vertex to vertex, back around again. And I can't promise you this is going to be pretty, but I will do my best. And so this is my best ellipse. Your best might be better. But this is what the graph of the ellipse would look like. Again, watch this video as many times as necessary, and feel free to leave a comment or question if needed. Until the next video, which will be hyperbolus 4 of 4 in our series. I'll see you next time.